Hi, everybody. Welcome to the webinar on benchmarking MongoDB on bare metal servers versus DocumentDB on AWS. My name is Cosmin, and I will be your host for today. A few words about myself. As I said, my name is Cosmin, and I'm a solution architect at Bigstep. And let's take a look at the agenda for today. First, we're going to talk a little bit about Mongo and DocumentDB. To ease into it. Then we're going to talk about the setup methodology for this benchmark, talk about node types, network availability zones, and then we'll move to the benchmarks we performed using JMeter, YCSB, and MongoDB social light tests. At the end of the talk, we'll take a look at the prices and draw a few conclusions. Okay, so I assume most of you know about MongoDB. As I said, in this benchmark, we'll take a look at the performance and cost aspects of running MongoDB on a bare metal cloud, Bigstep bare metal cloud, and compare the performance of DocumentDB from AWS. So to make it a fair comparison, we will use similar resources and identical load tests. As I said, MongoDB, long story short, it's a document-oriented database that offers a multitude of features: indexing, replication, load balancing, aggregations, and transactions. On the other hand, AWS Document recently launched at the beginning of 2019, with MongoDB compatibility. It's a fast, scalable, high availability, and fully managed document service. Just a quick note, Mongo offers MongoDB Atlas as managed services, but we will test the setup of MongoDB manually deployed on a bare metal and compare the performance. All the steps to make it the study impartial and easily reproducible will be available on GitHub, such that we performed in installing and performing the tests. Okay, let's take a look at a few key aspects of general aspects of a benchmark. So, a few things we have to take into consideration, and I found these aspects in a book, Evaluation and Benchmarking from TPC 2018. I have a link in the description. The main aspects are a benchmark to be relevant for users of the benchmark, being engineering, marketing, buyers. A benchmark must be repeatable. So in following the steps, you must get the same results. A benchmark also have to be fairness, both to hardware and software involved, verifiability in case of an audit, and economical. So economical to set up, to run, and publish a benchmark. So keeping this in mind, let's take a look on the type of nodes that we've picked for this benchmark. So you see in the upper table that we have 3 lines. Basically, after we performed the tests on Bigstep MongoDB cluster and AWS DocumentDB, we thought, okay, let's do another test and do a similar setup on AWS EC2 instances. Now, we picked relatively small instances for this benchmark, being instances with 8 threads and 32 gigs of RAM, to take a look at the Bigstep's instance. And the equivalent node in AWS specifically designed for DocumentDB is DB-R4-2-large that has 8 threads and 61 gigs of RAM. So we actually picked a little bit higher instance because the lower one would be 4 threads, and I thought it would not be as much as relevant as this one. Again, on the EC2 instance, we have similar node with M5-2-large, 8.32 gigs of RAM. Let's take a look at the general setup infrastructure. We have the location where you have a JMeter user interface. I will describe in the next slides how we use JMeter in this test that offers us control on a load node. We're using this load node for installing a JMeter server and also for load testing YCSB, benchmark, and social light. Basically, we're using this node to write data to the cluster. A cluster which follows a similar setup on all three deployments, having a Mongo server with acting as primary and two replica servers acting as secondary. Okay, so it's pretty clear up to this point. Now let's talk a little bit about the setup that we perform on Bigstep. Again, all the steps are available on GitHub, and I will provide links later. So this is how the basic setup looks in Bigstep. Basically, we started four instances and manually deployed Mongo on them. Just to note here, Bigstep does not offer MongoDB as a managed service as of this time, but we're looking to integrate it pretty soon. So basically the steps are to set up the private IPs on the three nodes, add the repo, and install MongoDB. Later you have to modify your Mongo conf file, add the replica set name, start the server, initiate, and add it to the cluster. As observation here, we're using MongoDB version 4.0. And now let's take a look on the other side at AWS DocumentDB. Here, the steps are as well pretty straightforward. And at the end of the presentation, I'll take a look at the time it takes to set up all of the three environments we're talking about. So you have to set up the cluster identifier, pick the instance class, number of instances, and deploy. Now, in order for you to either connect or use the cluster in AWS DocumentDB, you have to set up an EC2 instance. So for that, you have to deploy an instance, SSH on it, install the Mongo shell, and then basically connect to the cluster. Okay, DocumentDB is using version 3.6 for Mongo API. So in this setup, we're using, again, a low node on a EC2 instance and three nodes. Okay, I think up to this point, the setup is pretty clear. Again, the steps we've performed on this infrastructure are also performed on a different cluster on EC2 instances. Now, let's move forward and talk a little bit about the tests. For those of you who are familiar with JMeter, it would be a 3-5 minutes presentation on how to use the tool and how to use our custom sampler. But I think it's quite relevant because this is the step where we began the test, and later we added YCSB and social light. So let me just give you a quick description of these tools. JMeter it's a load testing tool mostly used for web apps, but it works very well on databases, has a lot of parameterization. This version uses reactive streams and Java MongoDB driver 3.9. The version that we are using in this test is JMeter version 5. Okay, YCSB, it's again a very popular tool when comparing relative performance of NoSQL databases, and social light actually came across to this type of test performed by MongoDB from benchmark that CDO of Mongo performed at the end of January, I think, where he compares Mongo Atlas with DocumentDB. And I thought, we should integrate this test as well. So all of them are described later on, and we'll take a look at the results. But first, let's start with JMeter. Okay, this will be a little bit of hands-on, I think. We'll follow, you also have the links available here. Let me see, just a second, let me see here. Okay, so in order to start this test with JMeter, basically we have to install it first. So just install JMeter 5, and then you have to download this sampler we've designed here. The author is my colleague Alexandre Bordet. And you have to download the jar and also make available the Java driver jars and reactive streams in lib/ext directory. Once we set up these steps, we can start JMeter. Just a second. Okay. Should start in a second. So all this test plan that I'm going to show you, it's also available on Git. Let me take a look here. Okay. So as key parameters, we see we have to set up the test type, the key and values that we insert or read from the database, connection string, database, and collection. We've implemented write and read operation, basic write and read, but also write many and read many. Okay, let me see if my JMeter instance has started. Okay. All right. So hope you're familiar, and this is redundant, but I'm gonna present you how you open a test plan. Again, this test plan is available on GitHub. Okay, and I'm gonna talk a little bit on each steps. So a test plan basically starts with a thread group, and this thread group performs an action. The action here is Java request write many, for instance. You see, when you set up the instance, you have to pick the class name. Here we have the Bigstep Mongo sampler. Then you configure the test type. In my case, is write many, and set up values for key and value pair. We are doing this by reading files from a generated file. See, you have here the variables name, comma delimited values. And if we take a look at the page, at the bottom, you'll see a script that is used for generating a file of keys and values, pairs. Okay, so once we set up the key and value, we move forward on setting up the connection string, setting up the database, and the collection. Okay, we're doing the same thing again with Java request read, where we set up only read action. And obviously, we do not have to supply a value for value. When we're writing, we can also set up an action to basically insert random values generated by JMeter. Okay, if we take a look at the thread group, here you can set up the number of threads and a loop count. For instance, we're actually simulating 50 threads and performing these tests few thousand times. I do not recommend starting this test on your personal notebook since it will be overwhelming for it. So we'll perform this test just for 80 iterations. Okay, here you can see the results, and I think we're ready to run. Okay. Let me take a look at the aggregated report. Okay. So we're basically writing now. This is done because on my test plan, I actually checked run thread groups consecutively, one at a time. So once the write requests are done, now it starts a read request. Here you can see the throughput. You have this test just to design it on your local notebook, but in order for the test to be relevant, we have to copy it to the load node. So doing that, you have to save it as a test plan and move it to your load node, where you can actually run it with this command right here at the bottom. Okay, so we'll get a CSV with the output. Output for 50 threads and 40,000 loop counts are the one that we see in the chart above. So we see at least double the throughput when we're writing single records on bare metal. And we see a bit of higher throughput when we're writing batch records on AWS DocumentDB. Okay, next one, I'm including the test performed on MongoDB on EC2. So we can see here a bigger difference when it comes to writing single records. Mostly, our conclusion is because DocumentDB is across at least 3 availability zones, where this setup on AWS MongoDB was set up in a single availability zone. Okay, let's take a look at the future step for JMeter, and this is something that our friends from Rodash, I think, can help us to perform a stress test using JMeter distributed testing. So basically multiplying the JMX file we configured on multiple load nodes, that we can actually bring the cluster to a point of where it will fail. So this is a part of a next step test that should be performed. Okay, so let's move forward with YCSB test. YCSB, it's a very popular tool. We set up this benchmark following the benchmark performed by MongoDB, and we actually used 3 different configuration files. Okay, we used configuration files for 50%, as you can see here. This is one sample file, just a second. One sample file where we read a portion of 50% and we update or insert 50%. Now, the load command, initially you have to load data in your collection, has different settings in terms of write concern. So either you can use replica, acknowledge, majority, or write concern 2 or 3. Actually, the options for YCSB depends on every version of MongoDB recently released. So you can see a difference in loading time when we look at loading 4 million records on Bigstep MongoDB. Took us 10 minutes, while on AWS took us close to 45 minutes. And I assume the difference is from the writing concern, setting up to majority, meaning that if our cluster is made up of 3 nodes, it should wait for at least another replica to respond that data was replicated. So we're basically in the second condition. Again, this chart is from the ebook I was earlier talking about from TPC TS. Okay, now the YCSB test, as I was mentioning, has different read preferences, settings, primary preferred, secondary, nearest, and this is how a data example looks like. I actually have 25 fields with BSON data. So if you take a look at 4 million records, it's close to 20 gigabytes of memory. Okay, so let's see how it performed, right? If we look at first test, where we're reading 95% of the time, there's almost twice the difference when we're running the test on bare metal instances and compared to DocumentDB. We can see a decrease as we move forward with our proportion of reads compared to writes, and you can see it's almost 3 times lower when we're looking at 50% reads and 50% writes. Now, we can also compare these results with results from MongoDB. I think it's here. The main difference is that they used close to twice the instance capacity in terms of CPU and memory. Okay, let's add AWS EC2 MongoDB cluster, where you can see it's basically better when we're reading 95% of the time, while at the read and equal reads and writes, it's close to 5,500 operations per second. Most of our difference, it's again from the network performance, and I think it's the CPU generation that is different on these 2 instances. Okay, Socialite, it's a very complex tool developed again by MongoDB that offers various load tests. So it has an interesting schema. It's actually using 3 collections. It simulates social network application using users, followers, and following. Again, the basic test starts with starting a Java loading number of user, followers, and messages. We perform similar measurements on both instances. Here you have a sample config file. It will also be available, and the command that we've run at the end. Okay, let's see the results. When we take a look at timeline read follower operations per second, you can see the Bigstep MongoDB clusters, again, almost twice the throughput. And after 45 seconds, they're basically stabilizing. Only that the DocumentDB follows a slightly descending path, while the cluster on the bare metal instances, it's a constant, I could say. Okay. Now, adding AWS EC2 cluster, we can see clearly a double in throughput for this type of operations. Okay, there's a difference, and I should mention the processor type in the beginning slide. I'll provide that details. I think I have them somewhere here. Okay, so in the beginning, I was talking about time it takes to set up on Bigstep and time it takes to set up on AWS. Now, not having a managed services gives us an advantage as well. You can actually configure a cluster according to your needs, and not being a self-managed platform, you can actually set up a sharded cluster which will offer you better performance. But it came with a trade-off in having to invest a little bit more time in research how you can actually do the proper configuration of your cluster. Obviously, on AWS, DocumentDB is ready for production, so we can actually start loading data as soon as the instances are up. Okay, so this is my time estimation and how much took us to set up the initial cluster. And just a note, we do not perform any customization on the cluster. It's a off-the-shelf installation. When you look at scalability, there's obviously a difference. On the bare metal and on the EC2 cluster, you have to deploy an instance, set up the IPs, and install MongoDB. And the last step is to add the node in the cluster. Now, on DocumentDB, it's a bit faster. Basically, if you select the cluster, just push it, and you can actually just add an additional instance. Set up an identifier and pick your instance class. Now, DocumentDB actually supports up to 15 replica reads. So, in case you're wondering if that's a limitation, it depends on type of workload you're looking to do with DocumentDB. Okay, so here is our time estimation for actually scaling a bare metal instance. Okay, so I think this is one of the last slides with comparison of costs. This is quite an overwhelming table, so we'll take a look. We actually look at the price for reserve and on-demand instances, compare the storage and type of instance. But let's take a look at this chart, which is easier to interpret. On the left side, we have Bigstep MongoDB, and the prices for cluster, reserve, and cluster on demand. In the middle section, we have DocumentDB, and on the right section, we have EC2 MongoDB. You can see prices are quite similar when we're looking at solutions that are not managed, while on AWS DocumentDB, it's at least 20–30% higher. Okay, I think we should have from this point 5 or more minutes for questions. Just as a general takeaway, you have to perform your own custom tests for your own problem in order to pick the right solution. That will give you opportunity to the right type of node to make it an economical setup and take into account scalability and flexibility of the entire solution. All right. So I think, okay, so a lot of questions. Primary DB, what type of operating system is used on the primary DB and replicas? It's CentOS 7.4. Just a second, you can actually take a look. Here is the instance type, and you can see what type of operation system. I think it's 7.4, yeah, CentOS 7.4. Okay, let me see another question. Okay, I think this is it. Guys, the presentation will be available on GitHub as well, and details on the setup. Okay. One more question. What resource became constrained first in all three environments? Okay, this is a good question. I'll have to look it up. It depends on what test you're referring to. Yeah, I'll have to look it up and see. Basically, we've hit CPU bottlenecks. So this is the main resource that basically hit the top. We did not perform the benchmark on a very large collection that we're actually running into memory constraints. So CPU was the main bottleneck. Okay, another question. Did the performance get hurt with a higher number of threads? Yeah, it's a good question, right on it. Actually, yes, it did. I started different setups, and with JMeter, for instance, if you're moving the threads up to, I don't know, 100, 150, you'll have a very abnormal behavior on bare metal, basically because we do not have any throttling mechanism in place. So you'll see inserts of tens or maybe 100 records per second, then delays while the messages get replicated. While on AWS, somehow the throttling mechanism works very well. Okay, I hope this answers your question. Okay. Okay, great. Well, thank you for attending, and I'm looking forward to even more questions. You can follow me. You can find me on Instagram or Twitter. You can write to our colleagues. I'm looking forward to more observation on how the benchmark was performed. Again, it should be taken with a grain of salt. It's not necessarily specific for application. Okay, another question is, this is a late one. I might have missed it, but do you perform any performance tuning? Both the bare metal setups and EC2 were plain setups. Only storage and network communication were set up. Okay. So yeah, I'm waiting for even more question and observation if you guys have any. All right, take care.